Hello and thank you for coming to my video today, guys. I'm really excited to make this video. It's going to be how to create a stake pool part 3. We're going to be going over a lot of important information today. I'm going to show you guys a better way to monitor your node. I'm going to be pulling up live view. To do that, we're also going to be messing with some settings. I'm going to show you guys how to update your pool or update Cardano node and Cardano CLI because it's really important for you guys to know how to do. There's actually an update that just came out, some CLI changes, and that's what I'm going to do in this video is show you guys how to update depending on no matter what get tag you're on. And I think that's really important for you guys to know. We're also going to be getting our stake pool certification done today. So your stake pools are actually going to be up and running. You're going to be able to produce blocks. You're going to be able to see your pool on FF testnet. I'm really excited to finally finish off this series. I might make another video after this with some more tinkering and stuff, but this is kind of the main ending almost, but there's going to be more coming, I promise. But before we get into the video, I run a stake pool called PayADA on the HTN. We currently have 5.11 million. What's also cool is we have a 12.3% average ROI, which is really, really high. I'm really excited about that. We've gone up a lot. We're up to 5 million again. That's awesome. If we can make it to 6 million from this series, I would be really happy about that. But either way, I'm still really content. I also have a Discord server to where if you guys haven't run into any problems while you're watching this, or you just want a community to chat with, feel free to join my Discord server. The link will be down below. I really like the way the Discord server is growing. Right now, it's like there's a lot of node support going on, but eventually I just want to have a nice community where stake pool operators can share information to help out each other, and then also just for average people to ask questions and just for us to have a good time. I also have a Twitter at big_pay. I post a lot of stuff on there. I also spam Charles asking him to come on my channel for a podcast. Might as well just say every day. Charles, please. But yeah, let's jump into the stake pool part of the video. Really happy you guys came today. Okay, so the first thing I'm going to show you guys how to do is actually update Cardano node and Cardano CLI. There's actually just recently an update for Cardano CLI in particular. So what you need to do that is we need to go to that Cardano node repository. And then we're going to be using those git commands that we used the first time we ever did this. So the first thing you need to do is fetch all of the tags. And then it'll fetch the origin. It's just essentially updating all the tags locally for you. So then we can do git tag. And then look, it'll actually show you all of the tags that you need. What we're going to be updating to today is 1.13.0-rewards. This just added a couple things, and it also is going to let you get your rewards from your stake pool. And then it also changed a couple CLI things. So you guys have to do this to participate in this video. Because there are different, what we're going to be doing today is generating keys for our stake pool, and the way you generate those keys is a little bit different due to this. So, and this is going to be the same thing for you guys in the future. Say when you're watching this video, it's going to be 1.14.0, and you're just going to have to stay up to date. You're going to have to keep your node going, and then after you do this, you're going to actually install Cardano node and Cardano CLI again, but it's going to be a lot quicker than it was the first time. So once you figure out what tag you want, like I said, we're going to be choosing 1.13.0-rewards. You need to do that to participate in this video. So you're going to type git checkout / tags, and then you do / and then the tag that you want. So you're going to do 1.13.0-rewards. I'm already on that, so I'm not going to click enter. But after you do that, the next thing you need to do is what you normally do, the cabal install Cardano node and Cardano CLI. And then you can also do the, if you would like to put, so what this does, it's going to put it in your cabal repository. So what you want to do is type in this command again, the command we ran in the first video. It's going to be exactly this. It's the command that is install. I'll just go ahead and type it out for you guys in case you don't want to go back to the last video. It's going to be install dir equals quotes and then # home /.local /bin and then the quote again. And then that's going to install those both in there. So there's two things you can do before you do this. You can either delete what's in there, or you have to have your repository set as overwrite. So you can delete the Cardano node and Cardano CLI in your path folder before doing this to get the updated version, or you could just go to your, after you run, or before you run that command, you're going to want to cd to your home folder, cd to .cabal, and then I think it's called config, so we should just be able to type nano config, and you want to scroll all the way down here and change your overwrite policy to always. I know I already mentioned this in my last video, but I'm trying to spend 20 seconds here to remind you guys about this so you don't have to go back to my old video. You need to make sure this is always, and then you want to save that, and you're good to go. You should be able to overwrite those this time, and then doing it that way where the overwrite policy is set to true or set to always, what'll happen now is it'll take a lot less time to install versus you just deleting them and then building them again. It should be a lot quicker doing it that way. Also, I had a lot of feedback saying that my videos are too fast, I'm going too quickly. My last two videos have been 40 minutes and 22 minutes respectively. I'm trying to take this slow, I'm trying to explain a lot of things, but if you guys don't understand any portion in this video, just rewind it a little bit and re-listen to it again, because there has to be a nice medium here for people that are learning this quickly and people that are learning this a little slower. The difference for the people learning this quickly is they can't just scroll back, you know what I mean? So I'm going to try to make this as informational and as concise as possible at the same time while also giving you all the details you need. So if you don't understand something, scroll back and listen to it again, and reiterating it will really help you out. So the next thing I'm going to show you guys is a life-changing feature for running a node. I should have mentioned it earlier, but I'm going to go ahead and knock it out of the way of this video. So you need to do this in both your node folder and your relay folder, but what we're going to do is just do it in our relay folder just to save some time on the video. You're going to want to nano into your config file. And then here you're going to want to change a couple settings. So go to trace block fetch decisions, change that to true. And then you want to scroll down and so you see simple view right here in view mode. And then you want to backspace that out and change this to live view. And you guys are about to see some magic. Go ahead and save that. And then once you're done saving it, you want to CD back to your pool folder depending on where you start your node at, and then you want to use your normal way to start a node and click enter. And look what happens. You have this live view of your node. It shows you your CPU usage, your memory usage, your mempool, and then most importantly over here, it'll show you your epoch/slot, your block number, chain density, blocks minted, your peers. If your node's working, it'll take a little bit for this actually to update because this is my first time starting this node. But what'll happen if your node's actually working is it'll show you the epoch and the slot going up right here. At the time of making this video, we're currently at, I can actually pull it up and look. We're currently at epoch 50, and this is what it looks like when it's working. I'll go ahead and make this a little bigger for you guys. So this is what it looks like when it's working. You can see my blocks minted, slots led. You can see my peers, and the peers is only at 1 because it's only connected to the relay. But this is what it looks like with a working node that also has the keys and the stake cert needed to run the pool. But we're gonna get to this point at the end of the video. But it is important for you to, for both of you guys, or for both of your nodes to be ran like this. I've been hearing a lot of people mentioning that they're having troubles because they're SSHing into the system and they can't keep their computer open. So to solve this problem, what I recommend doing is actually using SSH as we did in the first video and just leaving the node up and running. If you just leave your computer on, it'll keep everything going. There is another option to this. It's a little weird, but all you have to do is the way you run your node normally, you just type no hup in front of that, and then what it'll actually do is run your node normally in the background, and then it'll put all of that in a log file. So this right here, the nohup.out, that will actually be all of the logs that your server is outputting. This is one of the only ways that I know of currently to run it in the background if you are using a VM instance, like Google Cloud, for example, and then not actually using SSH. What I actually recommend you doing is just SSHing into it and then leaving your computer on and not letting it sleep. because that will leave it running. You'll be able to view the instance, but this no hup is another way to go about that. I'm going to show you guys another quality of life improvement, but the first thing that I'm going to do is actually stop this other node. And when you're in this page, you can use Q to stop it. So just remember that. So we're going to pull up this other one right here, and then we need to go ahead and copy what we normally use to run our node. So like we just said in the last portion of this video, if you would like to run no hup to run it in the background, make sure you include that. But we're not going to include that because I don't like doing that. So we need to make this socket path socket. Also want to include that. So then we're going to go ahead and copy what we normally use to start our node. And then we can go to that one file that we used to make, and it is called, or the bash file. So it's going to be bash/.bash rc. And then once we're here, we need to scroll all the way to the bottom again. And then we're going to make a new command down here. So we're going to call alias, and it's going to be equals. And then in quotes, what we actually want the road to, or we actually have to name it. So we're going to call this one relay, just because they're using this to start a relay folder. So if you guys want to have different commands and you want it to like run in the background, for example, you could do alias relay background and then include that no up command, or you could just do relay or node background. Just you can name it whatever you want. This is going to be what you're using to actually start your node if you want to proceed with this process. So we're just going to call this relay, and then we're going to equals, and then we have to add quotes, and then we're going to paste in that command, and then we're going to add another quote at the end. And then let me I do have it a little big here, so let me make sure it's not getting cut off or anything. It's not actually showing me. So yep, look, it did cut me off a little bit, so I'm going to backspace and make sure that closes it out. Make sure it's yellow like this or gold, and then you want to press Control-X, Y to save, Enter. And then I'm going to make this bigger for you guys so you can see. So then we can CD back into that folder. I'm actually already in it, so theoretically, if I did that right, we should be able to type relay, and it should work. /relay. Oh, I see what the problem is. We got to do source, and then the. So when you run source, you have to use the bash rc, and I'm going to go ahead and not cut that and keep that in here so you guys can see my my bad problem solving. So now that I typed in source, it should do this now because we updated it. Voila, we got a beautiful node. So you guys can do that with any of the commands you run. So if any commands, think of anything that you run in Linux, you can make your own variables in that bash rc folder, run source bash rc, and then you can start using those variables. It's just so nice. It's so neat. So if I were you, I would make one of those for everything that you need to do that, like for example, running the node. That stuff is really, really hard to type out, especially later on. At the end of this video, you guys are gonna see how long it is to actually run your block producing node. I mean, it's probably 100 to 200 characters. So you're not gonna wanna be typing that in every time. And it also gets kind of annoying finding it and copying and pasting it over and over and over again from your previous commands. So I wanted to show you guys that. It's finally happening. We're gonna start generating the keys that we need to run our stake pool, but I do want to make a little discretion here. This is not the way that you actually want to do this on mainnet. You're going to do the same exact process, but you want to do your cold keys offline. You don't want to be connected to the internet. That's what IOHK recommends. If you guys want more information on this, again, the link will be down below for the node key setup. They mentioned that they want you to create your cold keys on a computer that is not connected to the internet. But because this is the Haskell testnet and we're doing this just to get better with this, I'm not going to do that in this video, and I'm not going to do that in the Haskell testnet. I may do it once near the end to practice it, but I'm not actually going to do that on an offline computer today. So we're just going to create these keys as if nothing happened. So you guys are going to go to your pool folder. I'm on a different server than the one I made these other videos on, so it doesn't matter if you guys see a different lettering or anything. All the commands that I send you guys, they're going to make sure it works with the old videos, so don't worry about that at all. So in our pool folder, for me it's pools, because I'm going to have a couple pools in here, but don't worry about that. Make a directory called node-keys. So cd in the node-keys, and this is where we're going to be generating all of our keys. So we're going to do Cardano CLI Shelly node keygen, the old classic, but this one has node on the front of it. And then we're going to do verification -key -file cold.vkey, and then the cold signing key. So I'm going to reiterate this on this again, just so you guys remember. The V key is your public key, and then the S key is your secret key. You do not want to have your secret key connected to the internet in any way. But you do use your public key to actually figure out what your node ID is later, and we'll have more on that later in this video. I'm going to be honest, guys, this is probably going to turn into a long video. I'm not going to split it up into two. So now we can type ls again to see what we got. So we got our cold counter, our cold.s key, and our cold.v key. That means we're good to go. So now we need to generate our VRF keys. There is a lot of keys that you need for this pool. It's a lot more than the wallet. So then it's going to be -vrf, and then we're going to do the verification key file again, vrf.vkey, and then we're going to do another signing key file, vrf.skey. Did I spell everything right? Looks like it. Nope. What did I spell wrong? Saying invalid argument Shelly. Oh, I put Shelly twice. That's what it is. These are most of the issues that you guys are going to run into, is just typing things twice, putting characters bad. All the people that come on my Discord server for help, make sure you guys join that. It's all just character problems, and sometimes we need someone to check for us. And that's what we're here for. So we're going to generate some more keys, and these are our KES keys. Type in ls to make sure we have all these keys. We need the cold counter, the cold S key, cold V key, KES S key, KES V key, and then the VRF S key and V key. So then now we are going to have to do the issue op cert, and we have to do some math for this one. Okay, so what we're going to be doing now is generating our node.cert. You should have all these keys in this file except for the node.cert. I actually recorded this and did really well on it. I just didn't have OBS open, so got to redo it. So the first thing that we're going to want to do is we're going to figure out how many the KES period, and that's how many slots per KES period. And this may change for mainnet, so what I'm going to do is show you guys actually how to figure that out. It's pretty easy. You just take the slot number and then divide that by the slots per KES period, and then that'll give you the KES period. And then I'm going to show you guys how to do that. I know what I just said doesn't make any sense. So the first thing that we need to do is actually go to our Genesis file to figure out how many slots there are per KES period. Right now in the testnet there's 3,600. But we're going to go ahead and search that just so you guys can figure that out for mainnet, because it could be different. So what we're using here is a command. We're doing cat ffgenesis. This just shows you the file, the text in the file. And then this pipeline makes us start a new command, and we can do grep and then KES period. grep just is something in Linux that searches for this. So when we press enter, oh, got to add the .json, the old classic. So we can see that, look at search through there, it went through the file, found KES period, what we put right there, and we realized it's 3600. So what we need to do now is figure out what slot we're at. And then first, remember, we have to export our socket. A lot of you guys have been having trouble with this. You just kind of got to get used to referencing the right socket. I strictly use the relay. I've had less trouble just using the relay. It doesn't matter though. But I would also make sure you guys don't have this S here, because in the first video I had you guys create a folder called pool, but I'm going to have multiple pools in this folder, so I thought that it would be more fitting. So then also make sure when you guys start your node, the socket path is /socket. I've said this a couple times, but that's one of the issues you can run into. So after you guys export that, you should be able to query the tip, which is an easy command that I could have just typed in, but I typed it in just 5 seconds ago, so it will be up here. So Cardano-CLI, Shelly, query tip, testnet magic 42, old classic testnet magic. So then we get the slot number. And then what we can do now is do EXPR, and this is a little calculator. So we can take this number right here, paste it, and then we can divide it by 3600, because that was the slots per KES period, and we should get a number back. So 324. Cool. So now that we have that 324 number, sorry about that, had a little something in my voice. But now that we have that KES number, we can generate this node cert. And I accidentally, so we want to go back to that node-keys folder, and then I typed this command in earlier, like I said, because I already did this. So the command is going to be Cardano-CLI Shelly node issue ops cert, issue-ops cert, and then we're going to reference the KES verification file, which is kes.vkey. We're going to reference the public version of that, and then the cold signing key file, which is cold.skey, and then the operational certificate issue counter, which is cold.counter, which we made earlier, and then the KES period is 324, which is the math we just did. The slot number divided by the KES period number, which is 324. And then we're going to reference an out file called node.cert. And you guys want to go ahead and press enter. And then you type ls, and then you guys can do cat node.cert. And then it'll show you some good information, or it'll say error if you did something wrong. It might not even let you generate it if you did something wrong. But yep, that's how you get the node cert. And then now we're going to be registering our stake pool. Okay, for this portion of the video, we're going to be doing something very similar to what we did in the last video. So in the last video, we registered our Shelly address to the blockchain, but this time we're going to be registering our stake pool to the blockchain. It's a very similar process. Like I said, you're just going to have to create a registration certificate for your pool, and then we're going to have to use a transaction to register that to the network. But this part's also important because this is where you determine your pool pledge. And remember, everything's in Lovelaces, so whatever you want your pool pledge to be, you're going to have to take the straight number from UTXO, or you're going to have to take the ADA value and then times it by 1,000,000. Because, like I said, everything is in Lovelaces, which there's 1,000,000 Lovelaces in an ADA. In my opinion, it's kind of annoying. I hate it. But this is the way it is made. So there's also another parameter that we're going to be using called pool-cost. The pool cost is your cost per epoch. So if you want to charge 100 ADA per epoch, you're going to want to have 100,000 ADA. If you want to charge, or 100,000 Lovelaces, if you want to charge 1,000,000 ADA per epoch, which is stupid, it's going to be 100 million. I'm just giving you some math. So we need to register our cold V key, our VRF V key, and then our stake.v key. So those are all public keys. So if you were doing this on an online server, it would be okay. But you have to do this on an online. I don't think you need to do this. Yeah, you do. So you're using testnet magic. So you do need to be on an online server for this, but that's fine. So if you wanted to go about this the secure way, you need to generate all these keys, move them over to the online server without ever having the other server online. So we're going to go ahead and start building this. Maybe we should determine our pledge real quick. So for our pledge, we're going to be doing 100,000 ADA, and then we're going to be doing 50,000 ADA for my other pledge, because I'm going to make 2 pool certificates today. So all we have to do is start writing this out. So we got to think, if we want to do 100,000 ADA, that's going to be 100 million pledge. So you guys just need to do the calculations for that. So we're going to do Cardano-CLI Shelly stake-pool can't type today, registration certificate. Really can't type today. And then we're going to be referencing the cold verification -key file. And then if we're in our node keys folder, which you guys all should be, it's just going to be cold.vkey. And then the VRF verification file is going to be a vrf.vkey. And then the pool pledge, this pool is going to have 100,000 ADA as the pledge. You just need to make sure that you have enough in the wallet to do so. So I'm going to go ahead and copy this number that I calculated earlier, which is going to be 100,000 times a million. So now that we have that, we can do the pool cost, which I'm going to calculate. So for this pool, we're going to make it 125 ADA. So you need to take 125 and times that by a million, because this is in Lovelaces once again. I'm going to go ahead and do that in the Google calculator, because I want to charge 100 ADA per, or 125 ADA per epoch with this pool. So that's going to give me 125 million, obviously, but I do it in a calculator just so I don't mess anything up. So then the next thing we want to do is our pool margin. And then this is going to be the fee percent of the rewards. This is a pretty important parameter. If you guys were on the ITN, this is going to be the percentage that you want to charge. So for example, if you want it to be 5%, you're going to have 0.05. If you want it to be 3%, it's going to be 0.03%, and that's going to be 3%. This is out of the rewards. There's a big misconception that always goes around that if someone's charging 5%, then they're taking 5% of the total ADA delegated. That's not the case. It's the total rewards. So if you're getting paid 100, if your fee is 3% and you're getting paid 100 ADA per epoch in rewards, you're only going to get 3 ADA out of that, because the rest of the ADA is going to be distributed between everyone else. That's never going to be the case, because blocks are usually around 1,000 ADA. So if you get a block, you're going to take about 30 ADA out of that, maybe a little less, maybe a little more. The block size seems to be variable. But yeah, so you guys can just think about what you guys want for that parameter. But like I said, I'm going to go with for this one, we'll go with 6%. So we're going to go with 0.06. And then there are 2 more things we have to verify. So we need to reference our pool reward account verification -key -file. It's a long one, isn't it? So then we're going to be referencing our stake key. So for me, it's going to be wallets /wallet1. You guys need to make sure you guys are typing this in right. For you, it might be wallets-shelly1, depending on what you decided to name your stuff. So I have this in the wallet one. We're going to be referencing the stake public key, so that's stake.vkey. And remember, we're not in that folder, so you need to use this to reference something in your home folder, and then wallets, then the wallet one, and then what you're referencing. And then we're actually going to reference this again. So while we're here, we can go ahead and copy this, because we're going to need to paste it again. And then we're going to do the pool owner. And the reason you have to reference it twice is because you could have this as 2 different wallets, but we're just going to use the same wallet today. And then we need an out file. And then I have to go back and actually paste that reference correctly. So, yep, I didn't mess anything up, and I hope you didn't either, and you shouldn't have gotten any error messages. And then we registered our pool with the pool.cert. So now we just need to calculate the transaction fee and then submit that transaction, and then our pool will be registered. We're ready to go. And then after that, all we have to do is start our node with the keys that we use to make the certificate, and then our pool's ready. We're ready to be minting blocks. So now we're going to be building a delegation certificate. And to do this, we just need our stake V key, so our stake public key, and then our cold V key from the node-keys folder. These are both our public keys. I'll mention this one last time. Remember, you don't want your cold secret key on the server if you are doing this on mainnet. But I doubt you're watching this video for mainnet. You're just practicing, getting started. So we're going to do cordana CLI Shelly stake-address, and then delegation certificate. And what we're doing right here is we're making a delegation certificate to stake the money that we have in our wallet. Everything in that wallet is just going to be staked, and you just want to at least have your minimum pledge. So the minimum amount you need in that wallet is the pledge, and then also the fee to cover the stake pool transaction that we're about to make. So this is the stake verification file. That's probably -key file, as always. And then we're going to reference I think I might still have this actually copied. I do. So it's going to be in / and the squiggly line / wallets. Same thing we referenced earlier. And then we're going to reference our cold verification file. And this is the cold file that we made earlier for our stake pool. And that's just going to be cold.vkey because we're in the node-keys folder. That's why this works. And then we're going to make an out file for that called delegation.cert. That's good to go. So then now we're going to calculate the minimum fee for this transaction, and this does get a little bogged down sometimes. So the first thing we need to do is actually query the tip. I'll just go ahead and type it out so I don't have to scroll all the way up. So it's going to be cordana CLI Shelly. I have this one memorized by now. I'm sure you will too soon, once you start using scripts. So there we got our tip. And we're going to need this to calculate the minimum fee. And this one is kind of a B word to type in. I'm about to get monetized soon, so I have to start watching my language. Thank you to the overlord YouTube for infringing upon my speech. So we can do TX in count 1, and then TX out count 1, and then we're going to do the TTL, and remember this is the slot number. So we're currently at 1173074. So we're just going to put it way ahead so we don't have to worry about it in case we run into any issues. We're going to do 1173. We'll do 700. And then we have to reference a lot of stuff in this one. There's a lot of files that we're using, and that's why we actually have to calculate the fee. It's not the same every time. It's going to be different based on how many files you're using, like how many certificates and signing files, and this has a lot, so the fee is going to be pretty high. So we're going to do testnet magic 42, and then we're going to start referencing our signing key files. And then we need our payment.s key, so that's going to be, for me, it's going to be in wallets/wallet1, wallet-1, and then it's going to be payment.s key. We're using our private key for this. And then also I added a J at the end of signing. That's not good. Okay, so now we need to do another signing key file. And this one is going to be our staking private key. So it's going to be /wallets/wallet1/stake.s key. And then we're going to do another signing key file, cold.s key, and then a certificate file. And this is going to be our pool.cert that we made earlier. And then we're going to have to use that delegation.cert that we also made earlier. So it's going to be certificate-file, and then delegation.cert. And then we need to use our protocol params file. We made this in the last thing. I actually put this in my home folder to make it a little easier to reference. And it's protocol.json. So you guys might have this in your wallets folder. If not, if I were you, I would just add this again using the reference to generate the protocol params file. I would just generate that in your home folder. So then all you'll have to do is squiggly line / protocol.json. And that should give us the fee. Yep, so I did reference that file right, and then we got our fee at 18,5037. So cool. So now we need to subtract that. So what we need to do is query our UTXO, which we will do right here. And make sure you guys actually do this math yourself, because we are going to have different numbers. So I am going to have to actually go to my wallets folder to do this. Now I'll be able to get my TX. Okay, there we go. So now that we have that, we need to do the math for the fees. And then to do that math, we're just going to copy this number. We're going to do EXPR, and we're going to subtract that from the fee that we just came up with. So mine was 185,037. Remember, yours can be different if you're later on. But first we need to add that big number. And if I were you, I would copy this because it does mess up pretty often. I mess up my math pretty often on these things, and I'm sure you will too. And then we're going to subtract our pool deposit. I don't mean our pledge. I mean the pool deposit, and that's this number right here, which I think is 500 million. And it's because it's 500 ADA is the amount it costs for the pool deposit. So then we're going to press enter. We got that number. We're going to need that in our transaction build. All right, so now we're going to start building these transactions. And it's kind of the same way that we did it earlier. It's going to have we're just going to be using different files. And then the fee's a little bit higher. And then we also have to worry about our TTL. It's going to be the same thing as earlier. Our TXN is going to be the TX hash right here. And then we have to put #0 because that's what our TXIX is right here, #0. So if your guys' is 1, make sure you use #1 instead of #0. And then our TX out. What we're going to do is we're going to reference that payment address file. We're going to use the nice little cat command so we don't have to go in there and copy it. So we can do cat squiggly line /wallets /wallet1 /payment.addr. And then we need to do the TTL, which earlier we decided that was going to be, we can scroll up and copy that number. Hopefully we do it in time. And remember, it just needs to be in the future, further enough ahead so the time doesn't pass while you're doing it. So then we need to do an out file, just tx.raw, and then another certificate file. We have to reference both of our certificate files for this one. And we have pool.cert, and then we have the delegation.cert. Oh, yep, I forgot to add the plus and that value that we got earlier out of our calculator, which is right here. And that's kind of what you do for these things. You want to read the first thing it says, which is the option, not enough input. And then you can just come down here and look, okay, TX out, what did I do wrong? You know, that's how you solve problems in Linux. Forgot to do the fee, can't forget that. And look, same thing, just check the first line, it says, oh, fee. So then we have to scroll back up here and see what our fee was, which is the 18,50307 for me. Your guys's might be different. Paste that in, enter. error reading. Oh, it's because we're in the walls file, so it's always something. So we need to make sure we're in our node keys file. So we'll go to cd pools, cd node-keys, and now we should be able to run this command finally. There we go, everything's good. So then now we need to sign this. Then we need to do the tx body file, which is what we just created, tx.raw, and then the signing key file. Payment.skey. So we have to actually reference this right, so it's going to be squiggly line wallets / wallet1, and then it's going to be payment.skey. And then we're going to use our stake.skey in the same place. And then we need a third signing key file. It's going to be cold.skey. And then we're going to use testnetmagic42 for this. And then out file is going to be tx.signed. Cool, it worked. So when I went to go sign that, I actually messed up something. We're going to go ahead and correct that real quick. I actually had payment.vkey here twice. You just need to go ahead and change that to stake.skey. I had payment.skey twice. That was the issue, not vkey. But yeah, you guys are probably going to run into the same problems, and then sometimes you just need to have someone check you. So, and then if everything works right, you just need to submit that transaction using this line, and we shouldn't get an error, but we did. So I ran into an error there when I went to go try to submit the transaction. So you guys need to re-sign your file and change this to stake.skey and payment.skey. You just need to reference both the S keys and then also the cold.skey. So you can sign that, everything goes through, you're looking good, and then the last thing we need to do is this right here, Cardano CLI Shelly transaction submit. And if everything was done right, you should be able just to press enter, and look, we got no error messages, everything went great. A lot of you are probably going to run into error messages right there. There's a lot of arguments that you can mess up, but that's no worries. If you guys want to join my Discord server and ask for some help, push your error messages, sometimes you really just need someone to check for you, because it's usually always just a syntax problem, or if it says UTXO value not conserved, that means you did your math wrong. Just try to read what the error messages says. Some of it's like a little, some of it's kind of misleading and bogus, but there's usually one line in there that tells you exactly what your problem is. And that's the one line you got to send to us for help, or you can just problem solve it yourself. But okay, so then we have our stake pool registered. That transaction is going to go through. And then now we can actually search for our stake pool. Okay, so while we're still in our node-keys folder, we're going to type in cordana-cli Shelly stake pool ID verification key file, and then we're going to reference our cold.vkey. So like I said, make sure you're in the node keys. When you do this and you press enter, you should get this back. This is what you're actually going to use to look up your stake pool on Pool Tool. And then once you look it up on Pool Tool, you can actually name it on there. But first, before we do that, we need to make sure our node is running with the keys that we created to actually produce blocks. So what we're actually going to do is make this a little easier, and we're going to do that thing that we did earlier. So we're going to type in nano squiggly line /bashrc, and we're actually going to make a variable to run this node because it is a long command. It's going to make our lives a lot easier. I'm actually going to paste this command in the description down below to make this a little easier for you. So we're going to call this node-run, and this is going to be our block producing node in particular. And then you're going to paste in that command that I've pasted down below. And then after you paste it in, you want to add a little comma, or not a comma, but a single quote after that. and then we're going to save modified buffer, save it to bash rc, and then we're going to want to type source and then squiggly line dot bash rc because that updates it. And then we need to go back to our pools folder, and we should be able to type in node-run if everything went well. Heckin' yeah, everything went well. We typed in the command right. We referenced everything right. We have our node now. It's going to take a little bit to sync with our database again. It's going to use those keys, and it's actually going to start producing blocks. If you guys run into any issues, you're going to see it specifically from this epoch/slot, but it's no worries. It might take a second to update. If you do run into issues and it's not doing this correctly, you need to make sure you reference your socket right, and you also need to make sure that another thing you can do if your socket's referenced right, you're referencing the right DB. Worst case scenario, you can do rm space -r space db when you're in that folder, and then everything will be fine. But like I said, it just takes a few seconds. It'll kick back on. It'll take a second for your node to catch up, but voila, this is a stake pool running. It is now connected to the relay. It's going to be able to mint blocks, so everything's good to go. Now all we're going to do is take that key that we got earlier, and we're going to name our stake pool. Okay, so you guys might have started your node with that one SSH instance, so if you need to run that again, all you need to do is Cardano CLI Shelly stake pool ID, and then reference your cold public key. You need to get that address, and then now once we have this address, we can actually look it up on Pool Tool, and this is how we actually name our stake pool. Currently there's no certification or anything with the Cardano Foundation, so what you do is you take that key, you come to this website right here. I'll have the link down below. It'll be ff.pooltool.io. You take that and then you search it. But unfortunately, as I'm making this video, it's saying looks like we can't query the ledger state on the FF network anymore. So Pool Tool is going to be down for a bit. So my pool's the pool that we just created is not going to come up because of this actually being down. But there is no issue. Pool Tool will be back up. And because I want to finish this video and get it out to you guys faster, how you actually do this is you're going to search for this, you're going to find your pool, and then you're going to want to create an account. After you create an account, you'll be able to search for your pool, click it, and then name it, and then you'll be good to go. And what really sucks about this is I wanted to give my friend some exposure. He's actually supporting me a little bit to set up this pool. His pool, he's actually going to have two pools. He's going to have legacy and status. I wanted to showcase those and name those in this because he is supporting me in my channel by having me set up his nodes, and he's supporting me for doing so. So I really appreciate that. So when mainnet comes around, you guys will see legacy and status pools, and I had some part in creating those. But that is the end of the stake pool operator series. Before we go, actually one last thing I wanted to mention is your topology files. So you want the block producing topology file to stay the same, but unless you want to reference two relays, you obviously could add another relay in there. But what you guys need to do is mend your relay topology file so we can cd into relay, and then we can nano the ff-topology, and I haven't done it yet on here, but you guys want to either message me on Discord or message other people on the Discord server and find more people to connect to, because the more connections you have, the better your node's going to be. So all you guys need to do to actually add more peers, and you're going to see this on your relay node, it'll say peers at the bottom. You need to make sure the window's big enough for it to actually show it, but it'll say peers, and then if you have 10 people or 20 people, it'll say the amount of people that you're connected to, and the more is better. So to actually do that, all you need to do is add a comma here, press enter. It's the same thing that we did earlier, and then come all the way back out here and type in ADDR, add the address, and then you can actually name them too if you'd like. But just make sure on your last one, you get rid of this comma, and then also there's a comma on port, but there's not a comma on valency. So you guys can add as many people in here as you want. The more the merrier. If you come to my Discord server, I will give you my information so you can connect to my stake pool so we can get a secure network going. And then also maybe on my Discord server, we might get some sort of topology built with Big Pay's friends and family, all of the people that you can connect to, and we can make sure that we keep it up to date. And then I'm going to ask you guys to only include your IP address in there if it's going to stay the same for a long time, and then if you change it, you need to mend that document. But that's something that I'm going to be working on. Either way, I really appreciate you guys watching this video today. If you made it this far, it's awesome. You've listened to a lot of time of me talking. But if you guys made it this far, I always do this in my videos. Write, this series was a banger. And then write your stake pool name that you're naming it on FF Pool Tool. But yeah, like always, if you guys have any questions, be sure to join the Discord server and ask down there, or ask in the comments down below, but I do prefer the Discord server. Also, if you guys could just comment in general, it does push this video, leave a like, etc. But I really had fun making this series. It was definitely some harder videos to make, but it was worth it. All in the end, you guys all got your stake pool set up, hopefully, and then a lot of people in the Discord server got them set up. And hopefully with these videos, we can decentralize Cardano further, and then I give you guys a good introduction to Linux and a good introduction to Cardano Node and Cardano CLI. But this is wrapping everything up. There might be some more videos after this that's like some tinkering and stuff, but they're not going to be like these videos at all. So let me know what you guys think of that. I hope you all have a wonderful day.